Gamification. Do gaming components affect learning experiences? By Stacy Bond. The contents of this presentation are as follows. First, I'm going to explain why I chose this focus of study. Then I'm going to explain what game-based learning and gamification in education actually entails. That's followed by the main piece of this presentation, the review of the literature that I studied for this project. I will explain the model and methods that were used that led to the results. Then I'm going to wrap everything up with some final thoughts. But first, why did I choose this focus? Well, the classrooms of the 21st century are really dynamic environments. With the ever-changing needs of students and the evolving educational technologies that are available, it really is the responsibility of teachers to reflect and enhance their practice in order to meet all of the needs of today's classrooms. For decades, technology has been used to support learning in K-12 classrooms. But despite studies that show the potential of technology to promote student learning, many still struggle to offer data that validates the contributions of technology. Designing games for classrooms is not a new concept for instructional designers. Computer games for education have been around for decades. The earliest game was used in the 1970s by Seymour Papert and Wally Ferzig. It was called Logo Logo, and it actually blended mathematics and programming by teaching players the basics of coding by directing a turtle-shaped cursor to draw lines. When I typed in a search engine, math games, over 600,000 results came back. The job of a new age designer is no small feat. There are many components to gaming in the classroom that instructional designers need to take into consideration. The purpose of this assignment and this presentation is to examine how technology has changed gaming and to actually investigate the video game components with a focus on elementary mathematics. Are there specific components in video games that are more beneficial to learning, especially in math, than others? I've already mentioned that games in education is not a new concept. Other researchers, such as Nikolopoulos, explains in his research that play-based learning is actually rooted in Pigot's and Vygotsky's theories and still remains subject of research today. Game-based learning is using games to balance play with learning subject content and the ability of the player to retain and apply content to the real world. Gamification is the implementation of game features in web and mobile apps. Gamification is used to facilitate learning, motivate, engage, stimulate, and expand student knowledge. Basically, gamification is an evolved version of game-based learning, just tuned up a notch with technology. The 3 studies that I use for my research are all based in elementary mathematics. The participants for each study were grades 2 students up to grade 5 who had varying abilities in their mathematics. All 3 studies were similar in their methods. The first 2 studies were a little bit dated, and they grouped their students by classes, while the third study used the same group of students to study the non-gamified components as well as the gamified components. The first study used a purchased software called Skills Arena to help their 2nd and 3rd grade students learn math facts. In this study, there was a control group that used flashcards for their fact skills, while the others used the video game. The picture here shows the game and the flashcards that were used. The second study used software that was created for the study to help grade 5 students pose problem questions to improve their overall math knowledge. The third and final study was the study that I thought was the most dynamic. Set up 4 different studies for the same group of grade 2 students. There was a non-gamified digital lesson that's pictured here. The second was a competitive condition where scores were kept. The third was an adaptive condition where students actually competed against themselves in a narrative-based scenario that contextualized the game. The fourth and final experiment was a collaborative condition that encouraged students to work together. Although all 3 studies came to the same conclusion, that gamification is beneficial to teaching elementary school students math concepts, there was a few ideas that arose that are worth mentioning. In the first study, the one where students were learning basic facts. The students who used technology outperformed those who did not use technology. But the interesting part is there was not a significant difference in the math scores on the final test. There was a second part to this study, because the researchers thought the relationship between learning characteristics and learning using technology might be the reason for the close scores. But after further review, there was not a significant predictor of test scores based on individual learners. But the interesting part, that I thought it was interesting anyway, was that there was speculation about specific teaching that influenced the results of the study, maybe saying that good teaching beats out technology in this case. The second study had similar results. This study was delivered to grade 5 students using the problem-posing software. The features of the system allowed students to reflect on their posed problems and practice over and over again. Through system function, comments, and feedback, the results were clear that games not only improved math knowledge, but they also influenced a higher interest level in math. In the third and final study, there was a downward trend in the non-gamified condition, so students actually solved fewer questions as the time passed. The other 3 conditions that were gamified showed a positive trend of number of problems being solved as the time progressed. The adaptive condition in the gamified study led to the highest performance compared to the other conditions. The difference between the adaptive and the non-gamified conditions was quite significant. But also interesting to note, the adaptive condition also caused the most amount of stress and actually had the most amount of incorrect tasks completed. The narrative and the storytelling elements were not significant alone, and the real strength of gamification comes from the combination of carefully interconnected different gamification elements. Once the algorithm allowed for more task completion time, students were motivated to start competing again. The setup significantly increased the incorrect attempts by students. Additionally, the performance trend in the third grade students was higher in the competitive gamification condition. This probably indicates that this approach might be more appropriate for older students. Now for some final thoughts. I believe, and this study proves, that students who are given tasks that are balanced with their skill level will be more engaged, and in other words, they'll experience flow. Flow is one of 8 mental states that can occur during the learning process. The other 7 are anxiety, apathy, arousal, boredom, control, relaxation, and worry. If a task is too difficult, a student will experience anxiety or worry, compared to if a task is too easy, they'll become relaxed or bored. Flow will result when a learner experiences an optimal combination of skill and challenge. And this was true in the studies I looked at today. Students experience flow during the adaptive condition of competing against personal limits in the narrative-based scenario. After feedback was given, changes were made to the game's algorithm so time could be reduced if the student was outperforming the game, or it would allow more time if the game was catching up or beating the student. In other words, the algorithm was designed to keep the students at the edge of their limits. Overall, in all the studies that were examined in this presentation, student performance in mathematics can be greatly enhanced with the gamification and integration of technology using careful combinations of different game elements. Thanks so much for listening.